Welcome back to Post Projects and Project 818 SRX. Before I dive into all this, I'll quickly ask for all of you guys watching on Facebook, if you can do me a favor and hop onto YouTube and give me a subscribe, that'd be great. YouTube has this analytics thing and tells me that pretty much all my videos are watched on Facebook, so help a brother out. So in the last video, when we disassembled the engine, I did a quick review of what would need to be replaced, or what I thought would need to be replaced, but I did say I was going to take it to an expert. I did. I took it to see Adam at RX-7 Specialties in Calgary, and he pretty much confirmed all the things that I knew. The housing was trash, the rotor was trash, the bearings were obviously the result, or were the cause of the failure. The bearings also had blued the gears quite bad. So there was no obvious chips, but there was a lot of heat damage and a bit of scoring on the inside from when the bearing failed. So the stat gears also need to be replaced. And of course the E-shaft as well was all blued, and you could feel marks on the front and rear stationary gears, wear marks. So those all had to be replaced. So I got all those from him. I went with a used but resurfaced housing to replace the rear. I also went with a used rotor to replace the rear. I went with a RX-8 eccentric shaft and RX-8 stack gears. Now, you can run an RX-8 eccentric shaft in an FD motor. I don't want to comment on the previous models. Contact an expert, but I'm sure it works fine in the FD motor. The only issue is a slight difference on the front in the location of this little hole and where it lines up. So what they offer at the RX-7 Specialties is they slightly chamfer this hole so that it lines up. I think it's a 4mm offset. Doesn't even look to be that much lining it up. Very minute. The RX-8 shaft is lighter, if you notice. So this is the FD shaft, and we've got 3 holes, one big, 2 small, on both ends there. Get that one out of the way because we're not reusing that. And then on the RX-8 one, we've got 2 large holes and 2 small ones. As far as balancing, you wouldn't need to, like, this shaft becomes balanced, so you wouldn't need to balance this as part of the assembly. Any jig I've seen for balancing rotors and counterweights, flywheels, doesn't involve the E-shaft. So this itself is balanced. By my bathroom scale, it's about a pound lighter. I've seen some comments on the forums saying half a pound. I don't have an accurate scale that, for measuring something around 15 pounds. I got this one at 14, the FD one at 15. Either way, it's a little bit lighter. It's a lot cheaper. I got this new one for about a similar price as to what I'd buy a used FD one. A new FD one is at least twice as much as this one. It was enough that I didn't consider it. And then I just went with the RX-8 stack gears. So it's not, these line up perfectly with these holes. It's a slight chamfer so that it lines up with the oil passage in the plate. And he does chamfer both of them, although the internet tells me that it's just the front one that's an issue, but I'm going to go ahead and trust the experts on that one. So, new E-shaft, new stack gears, and of course new bearings in those. This one even has the rear main seal already installed. Okay. Balancing. So I did get my let's jump on the rotors next. So if you notice, I got a big F and a big R on my rotors. That's because I had them balanced. I also had them clearanced, which is just a slight cutting of the tips. It helps at higher RPM, supposedly. I was getting machine work done. I figured, why not? I didn't go for lightning. That is another option. that gets more expensive, and the bill was creeping up with all the parts I had to replace. They of course have new bearings already installed. Just those easy things that, hey, if you're bringing it to a shop, get those things installed so that you don't fuck them up yourself. So they have to be run front and rear because this is how they were balanced. So when they're balancing it, they have two of these set up on a balancer. If you go to RX7 Specialties YouTube page, you can see how they do that. And then they also use the counterweights. So I brought them my counterweights. So those are set. And they did have to take out quite a bit of weight. Both of these spots here are rather deep holes. I mean, they're over halfway through. Probably a good 5/8 hole is milled down in. So there was some out of balance. Now, obviously, and the rotors were balanced individually themselves as well, and you can see that a little bit. Yeah, this hole here was taken out a little bit, but the whole assembly was balanced, and this was the main correction. The front doesn't appear to have any corrections made to it, the front counterweight, but the rear counterweight had quite a bit. And again, this is not original to this engine. This is something I added to run this flywheel. So there definitely could have been a slight imbalance going on there. So now we are perfectly balanced, as close to perfect as we're going to get. I also had my flywheel balanced just because this is an unknown, and they did take some weight out of this. Not a huge amount, but there was definitely some weight taken out. So if I was going as far as to get everything else balanced, why would I just stick a really heavy, actually, flywheel on the back that wasn't balanced? Okay, since we see these here, I'll briefly touch them. Besides the RX, I wouldn't even consider it an upgrade. It's an economical option. The RX8 E-shaft and the two stationary gears. I'm also going to run a Racing Beat race regulator to crank up the oil pressure just a little bit. Just nervous about oil pressure. And I'll briefly mention I did manage to get the logs. I recorded a log when I drove to the shop the time I had an oil failure over a year ago, October 2019. And I couldn't get the log to work. It had done an automatic save and it wouldn't open in AEM Infinity software. It did, however, open up once I was talking to an actual AEM tech. It did open up in AEM data, and I was able to look into it, and it looked like, okay, well, at the end of the log, and I'll try to impose it here, it looked like the last minute of the log, it dips down to about 40 psi and stays there at like 3,000 RPM. Now that's lower than it should be at 3,000 RPM, and it just kind of stayed there. And I'm like, oh, well, maybe the oil pressure didn't drop that much. And then I looked at the length of the log, and the log had done an auto save at 10 minutes. The first minute and a half of that was idling here in the driveway. It's a 25-minute drive, at least 20 minutes. So that means that about 7.5 minutes into that drive is when the oil pressure dropped down to that 40 mark. It was there for about a minute, and then it stopped recording, and then I was driving for another 10 minutes. It was much later than this that I noticed it on the gauge. At the time, I didn't have my CD-7 set up to give me warnings on oil pressure. It was just a little needle in the corner. First time driving the car, I didn't really notice it. I've since corrected that. It now will tell me I've set oil pressures for each 1,000 RPM. If it goes below that, the whole screen goes red and tells me. So. All the oil lines have been upgraded, so running the little extra pressure shouldn't be an issue. So I'm going to use that. Apex seals. I'm not going to use factory apex seals. I'm going to use E&J two-piece. There's all kinds of comments and opinions on apex seals. So these are a two-piece steel apex seal. They generally will have decent compression, and if there's any detonation from poor tuning, which I hope won't happen, but is possibility. I'm an amateur at tuning. They won't shatter and destroy everything and shoot out and wreck my $3,000 turbo. They'll just warp a little bit. They are hard on housings, but that's the sacrifice you make. There's no real one cure for or one apex seal for all applications. It's kind of a unique choice. And as far as two-piece apex seals, there's probably at least a dozen out there. There's probably 5 or 6 popular choices, and very few people that have run the same apex seal in the same configuration with the same tuning. There's so many variables that I think people just have a bad experience on a motor that may or may not have been the cause of the apex seal. They blame the apex seal and then they go to a different brand. It doesn't happen the next time because they fixed that problem. Well, now they think the new apex seal is so much better. It's not necessarily true. But I couldn't really find anything bad about E&J. They've been around a long time. From what I can tell, it's pretty much all they make for rotaries. But I got those from Lucky 7. And studs. So this is a factory 13B stud. This is what goes right through the whole engine for bolting it down. I should say stud. This is a bolt. So the factory bolts, these are considered reusable. I guess there's no real issue with stretch. However, I'm going to be running these, which are the Turboloan or Turbo Source 13B studs. So it's a stud and a nut versus a bolt. And there's again difference of opinions on whether or not running 10mm studs does anything for a rotary. When an engine is studded, this is not what they're referring to. They're referring to the holes are enlarged so that a 1/2-inch stud tightly fits, almost like a dowel, like additional dowels, through the whole engine, and it's preventing that twist. This is a little, so they are a 10mm stud, and this is a 10mm bolt. However, this measures 9.5 mils, and this measures 10. So it does fit a little tighter in the holes. So there is some, if you don't believe that clamping force matters for a rotary engine, then there is still a little bit more protection for deflection. But those are my upgrades. Now, besides that, let's get into my plates. Now, I got some porting done. So this is my front. You ready for this? Well, first, before I turn it, this is opened up. RX-7 Specialties offers a CNC porting option, which you can get them to finish it by hand, or in this case, I opted to finish it by do the hand finishing myself. So they CNC port in through here, and then they CNC port here, and that's a bridge port. So if we look in here, it's still rough on the inside where the CNC wasn't programmed for, and that stuff I'll have to clean up by hand with the die grinder. But the bulk of the porting is done, and certainly the shape is done. The cut here is done. I like there's a what I would consider a safe amount left on the edge of the water seal. Sometimes you see them done by hand and they get scary close to that. So I'm really happy with that. Other than that, if it looks cleaner than last time, they do like a media blast, and it is quite clean. Okay, now the nice thing that they offer, that if you've watched their videos, is at the same time they do this relief right here, so that when you lay the bridge on there, let's see if we can get this lined up. The bridge port actually, I should have a close-up video here. The bridge port lines up with a notch in the rotor housing, so that airflow can actually get in. Because if you don't, I totally had that backwards.
Are you stupid or something?
Stupid is as stupid does, sir.
So if you don't have that lined up, then having the bridge even remotely close to the water seal would be pointless. you're not accomplishing anything because it's just going to hit a wall, which would be the edge of the rotor housing, as it would have looked when I had this on backwards. So let me just get this front plate out of the way. So I've also had the exhaust ported. RX-7 Specialties actually removes the pins and it replaces a threaded little needle stud, and it's been opened up a little bit. It's not opened up crazy. I think this is kind of like their street port size, but it's that D shape that we're often familiar with seeing, and it again, a CNC port. It's kind of perfect. It's just they just take the sleeve out and they just come in from the inside and cut that out. So and then this is the new rear one actually, and it's just a resurfaced one, used one. Now, yes, I did go full bridge. So these are the primary ports. They're also a bridge port. Now, if you're looking at this bridge port and it looks different, then I'll bring out the rear housing now because it's not anything real special. Because this is your typical big street port you're used to seeing. This is on the secondaries, and then here's your bridge. Ports are a bit smaller. I believe that's a limit to the casing. Also, it's going to help with idle on a typical throttle body setup because the secondaries wouldn't get opened until later. My setup, I have one throttle body and it opens up to all of them. So idle might be tricky, but that's okay. We'll look at that. I didn't build the car to idle. So if you notice the bridge port, the eyebrow as it's often called, is quite short. And a lot of times you'll see a bridge port where this is pretty much just as long as the main port itself. This is what RX-7 Specialties consider their turbo bridge port. So they run a shorter one for the turbo engines, they run a longer one for a naturally aspirated. It has to do with overlap and other considerations that I didn't really get into. Again, just putting a little faith in experts here. Now, some might look, well, only half of it's bridge, so that's a half bridge. Well, there's no golden rule. It's not like Mazda ever made a, sorry, the rattling there. It's not like Mazda ever made a paper that said, this is what a full bridge is, this is what a half bridge is. But the general understanding for the industry is if you bridge port the secondaries, it's a half bridge. If you bridge port the secondaries and the primaries, it's a full port. So it's half bridge if it's just the secondaries, full bridge if it's secondaries and primaries. It's not a reference to the length of the bridge, although I'm sure someone will disagree. So what I have to do now is I'm going to show you guys what's involved, and I'm really making it up as I go. I'm pretty decent with a die grinder, so I'll be putting some tape on these faces so that I don't accidentally nick or mark anything, and I'm going to try to do as much as I can through this port because any work you're coming in through here with a die grinder, you can't fuck up the irons, the face. If the rear looks a little cleaner maybe, I did have to get the rear iron lapped. You can still see the slightest wear mark right here, but you can't feel it at all. It's a little bit of a gouge from the happenings that went on in the rear rotor, but it's no longer an issue. The other iron faces were deemed acceptable, so I was thinking I might have to get some of them lapped. I just had to get the one out of the 4 faces lapped. While I'm die grinding, I'm also going to clean, well, I'm going to clean up that little casting bit right there because that's sharp and that looks ugly. But the oil pump is actually quite rough, and I've seen pictures of guys cleaning that up with a die grinder, and now is the perfect time to get that cleaned up because there's 0 oil and grease on this, so I can die grind it and I can blow it out with air, spray a little brake cleaner in there, and I'm not going to be concerned about trapping filings that are going to get into my oiling system and mess up my bearings or my turbo or anything like that. So if you're still watching, let's get into some tie grinding. I do have this port all cleaned up and it's smooth. I should be overlaying some video there now showing that port. So that's the rear secondary. This would be the front secondary. And you can see there's like, you know, the lines where the CNC stopped and that I had to blend out. Same thing if you go in through the ports. There's a line 3/4 of the way down that you've got to grind and blend off. While I'm at it here, I also did a little cleaning up of the casting around where the oil pump mounts. I didn't port it per se. I did round off a few edges, but really along this center rib on either side, the casting was just so rough. And I noticed in a few spots the casting was just terrible. Even just looking in where the water pump hooks onto the coolant ports, just big old scabs of what, you know, looks like a little bit of cast iron and almost sand in it. You touch it a little bit with the grinder and it falls off. So anything I could find like that, I decided to get off, because you wouldn't want that getting into your oiling system or your cooling system. So I've got the tape on there, so when I'm doing my porting from this side, if the die grinder does skip up past the edge, which I'm making every effort not to, it'll hit the tape and give me some buffer. I mean, obviously it would chew through the tape, but as soon as you start to screw up, you immediately stop. So a couple of times I just touched the tape, but there was no imperfections or whatever on the plate. Let me lay that down. And same goes for the primary ports, which are considerably smaller. That's just due to the casting. The earlier housings, you could have as big a port on the primaries as you do on these secondaries, but you can't on the newer turbo ones. I'm not sure when that changed. It might have been 12A to 13B. But I've cleaned this one up and it's quite smooth. Something I do want to briefly talk about. If you watch the RX-7 Specialties video about, here's my little drawing, about the CNC porting, he mentions that the bridge port is done. It's finished. It's complete. And it would work fine as it is, for sure. It is complete. However, I would suggest that it could go a little bit further. So I'm not thinking I'm better than an expert here. It's looking at other experts' videos and just reading between the lines, the little things that you can do. So what I did here is, this is the bridge port. We're looking at this one here now. I'll leave that one there. So we're looking at this one here. Here's a copy. If we just do a side cut of that, and then this would be your main port, and then here's your bridge, which is this area between the two ports, and then this would be your bridge port in here. So your ear is coming in through the port, and it wants to go right past the bridge port and up into the rotor housing. Now I understand there's velocity happening, there's pressure happening, so it is going, like, air is going to spill. It's not going to skip past here and not go in. Air will spill into the bridge port. However, one could argue, I'm just screwing this drawing up completely here, that the square shape on the bottom isn't ideal. So if you watch some other guys porting, I'm gonna single out Kyle Mulhan. He likes all my Instagram posts, and I was watching his video last night, and he actually rounds off right there, and then I believe this one right here. So that's rounded, that's rounded. So when the air, which is, you know, somewhat sticking to the wall on the top side there, and the blue pen back, you want that D shape he refers to, so that the air that's flowing along here wants to flow up that way. And the same could be applied for right here. It would just help less turbulence. You don't need to square off, you don't need to round off this one, because you don't want the air, any air that goes past that bridge initially, you want it to just go into the main port anyway. So rounding those off is a little tricky. With the bits that I had, this was the smallest one, and it just didn't quite get in there, and I was able to get a little bit from the inside using a bit like this, where you can come in and you can kind of take that off. I did order some more bits that are smaller, that I can kind of take that edge off a little bit. And then to finish it, I really like Kyle Mulhan's trick. I've got some like emery cloth. He uses, I think, like an 80 grit sandpaper. You cut it in a strip, you feed it through the bridge port, and then out through the main port. And I mean, it takes a little while because it's steel, or cast iron, but you can really smooth that out and get that nice flow in there. And I really appreciated that trick, and I wanted to pass it along for anyone watching this. Other than that, I noticed all kinds of just nasty little castings that just bugged me. I don't know which one now because they're cleaned up, but like these ports, there was one of these that had a ton of it blocked off. Just real thin castings that I just wanted to touch up. The nice thing is that these were completely cleaned and there's no oil and grease on them whatsoever. So it's the perfect time to do that stuff because I can clean it out with air. I can blow out all the passages and get them clean and not worry about all my filings getting stuck to the wall where there was oil and grease, and it getting into the oiling system or the cooling system, which would be bad. So next up, I'm just going to finish these ports. Again, it's hard to film. I've got a couple of them finished to show what I'm doing. So I'm going to finish up these ports, but that's going to be it for today. The next up is going to be assembling the engine. We've covered the parts, we've covered the porting. Now it's time to just assemble the engine. I'll probably just do one long video of putting the engine together. So as always, thanks for watching. Really appreciate all the feedback. If you get a chance, like I said, I'd really appreciate a subscribe. Really close to that 500 subscribers number. That's kind of my goal for the end of this engine build, is to get to that point. And with any luck, we'll have it fired up in the next month or so. I won't be able to drive it. It is Christmas time now, just about. I'll be able to fire it up, idle it here in the garage, but I won't be able to drive it for at least 3 months at the earliest, probably 4 months realistically. But the goal is to have the car ready long before that. And there's some other upgrades that I'll get into that I'll probably take care of in this time. But I want to make sure this engine is ready to go. I don't want any delays in the spring. So until next time, like, subscribe, peace.